Russ Jackson, welcome back to the show. Today we're diving into customizing builds with release profiles in Rust. Can you give us a high-level overview?
Sure, Matthew. Release profiles in Cargo are basically different settings for compiling Rust code. Think of them as different gears for a machine. You have a development gear for quick, iterative builds and a release gear for optimized, production-ready builds.
So, these profiles affect how the compiler behaves?
Exactly. They control things like optimization levels, debugging information, and more. Crucially, each profile is independent. You can tweak one without impacting the others.
What's the practical difference between dev and release?
The dev profile prioritizes fast compilation. It doesn't apply as many optimizations. This is great for when you're constantly building and testing, you know? The release profile, on the other hand, focuses on the final compiled code speed. It applies heavy optimizations, leading to quicker execution, but it takes a bit longer to compile.
So, this is like optimizing a financial portfolio.
Chuckles. Exactly. Dev mode is like actively managing investments, needing quick feedback. Release mode is like a long-term portfolio, focused on optimizing returns.
Okay, how are these profiles actually defined?
They're specified in your cargo.toml file. There are sections called profile.dev and profile.release. These hold settings for each profile.
Let's say you want more optimization in the development phase. How would you handle that?
You'd add a line like opt_level equals 1 inside the profile.dev block in your cargo.toml file.
So, you can customize specific aspects of each profile. That's powerful.
Yeah, you can customize practically anything about the compilation process within each profile. You can control optimization levels, debugging information, or even features specific to different target platforms.
What's a common misconception about these profiles?
Sometimes people think changing the release profile affects the development builds. But they're separate.
And what are some real-world scenarios where customizing release profiles comes in handy?
Imagine a game. You might have a very high optimization level in the release profile to squeeze every last bit of performance out of it for launch. However, during development, a lower optimization setting in the dev profile might be better for quicker iteration.
What if you encounter compilation errors during release mode?
You'd first check that you set the configuration correctly. For example, you might have made a typo. You'd want to double-check the cargo.toml file.
This is really helpful. Thanks for explaining this nuanced topic in such an accessible way, Russ Jackson.
Of course, Matthew. It's all about understanding how different configurations in your cargo.toml file can optimize the building process and enhance your Rust projects.
Thanks for shedding light on customization in Rust builds. Great insight. Russ Jackson, welcome back to the show. Today, we're diving into documenting Rust functions. What are some key sections we should always include?
Hey Matthew. Crucial, especially for maintainability. Documentation helps fellow developers, and even yourself later on, understand the function's behavior.
Right, so what are some common sections?
Well, panics is a big one. We need to document situations where the function might crash. Think about unexpected input, you know?
So, a function might panic if given invalid data?
Exactly. Callers need to know when they could cause a panic. It's like a warning sign for potential issues. A counterexample would be a function that always works correctly, no matter what input. Documentation would be much shorter, or even non-existent.
And what about errors?
Errors are often returned via the result type in Rust. Documenting potential errors is extremely useful. We need to clearly describe the different types of errors and what triggers them. This lets users handle those errors appropriately, preventing issues later.
That's great. So a user can write specific error handling depending on the returned error, preventing crashes.
Absolutely. Think of a financial application. A function to withdraw money might return a insufficient funds error. Users need to know about this for defensive programming. It's part of writing robust code.
What about safety?
Safety is crucial for unsafe functions. These functions often deal with raw memory and have potential risks if not used carefully. The documentation explains the unsafe aspects, outlining the conditions users need to ensure for correct behavior. Imagine a function dealing with a complex financial instrument. The safety section is crucial for guaranteeing stability in that transaction, or you could have a loss on your accounts.
So, the documentation helps prevent crashes and allows the users to understand how the function might fail.
Precisely, Matthew. Documenting these aspects thoroughly leads to much more maintainable, stable, and error-free software, especially when handling financial transactions.
Great points. So, documentation isn't just for looks, but for actual usability?
Exactly. Think of it as a helpful guide for other developers, or even yourself, helping everyone understand the function's behavior and potential issues, making it easier for everyone to use it responsibly.
Thanks, Russ Jackson, for clarifying these crucial documentation sections. This is invaluable for creating robust and usable Rust functions.
My pleasure, Matthew. Always happy to discuss the finer points of Rust and coding.
We'll be right back after a quick break. Russ Jackson, thanks for joining us. Let's talk about documentation comments. You mentioned they can act as tests. How does that work?
Yeah, it's a really cool feature. Imagine your documentation not just explaining what a function does, but showing it in action.
So, show me what kind of code?
Well, you'd write example code inside the documentation comments. And when you run cargo test, it runs that code as a test.
So, the examples become tests?
Exactly. If the example code changes or the function code changes and they don't match, the test fails, which is great because it alerts us immediately.
So, it's like a built-in check for consistency?
Right. Like, if you write a function that adds 1 to a number, and you have an example in the doc showing how to use it, if the example code gets out of sync with the actual function, the test will fail.
So it forces us to keep our docs and the code together?
Exactly. It's awesome for keeping things in sync. Think about maintainability. What if a programmer changes something and doesn't update the documentation correctly?
Big problem. And what happens if the doc test fails? What kind of output do we get?
You'll see a clear failure message, similar to other tests. You get the details on which test failed, and more importantly, where the error occurred.
So, a simple way to improve documentation quality automatically?
Definitely. It's a great practice to build into our development workflow.
What are some real-world examples where this is especially useful?
Any financial or scientific application that needs extremely accurate and dependable documentation. This type of automated testing becomes critical. The accuracy of financial models or scientific calculations depends on precisely matching the example usage to the implementation.
What are some common misconceptions about this feature?
Some people think these are just extra tests that add to the build time, but they're actually integrated very efficiently. It's a side effect of the already existing test infrastructure, not an extra burden.
So it's not just documentation, it's active quality control?
Exactly. It's a safety net and saves us from potential problems down the road.
How can developers implement this in their projects?
Just put your examples in the documentation comments, alongside the function definitions.
How about error handling? Does this automatically check for errors?
Yes. Any error raised during the doc test will cause the test to fail.
Great. So, it's more than just a way to make the docs clearer. It's also an active quality check. Thanks for explaining this, Russ Jackson.
My pleasure.
Russ Jackson, welcome back. Let's talk about documenting Rust code. We've been discussing functions and modules. Now let's dive into documentation.
Sure, Matthew. Documentation is key, especially in a language like Rust where the code is often complex.
Absolutely. This chunk introduces a special type of doc comment, starting with //. What's the difference? And when should we use it?
Good question. A regular doc comment, starting with // documents the item after the comment. // Comments document the item containing the comment. Think of it like a summary for the crate or module as a whole.
So if I wanted to describe the overall purpose of a crate?
Exactly. //. Comments are great for a crate level or module level overview. It's like a table of contents, letting users know what a crate does before diving into specific functions.
And where would we typically put these?
Usually in the src/lib rs file, which is the root of your crate. You want to set the stage for users, outlining what's contained within.
So, it's like a preface for the entire crate. Practical example?
Imagine a crate for financial calculations. //. Comments could describe the purpose of all the financial operations within the crate. It provides a high-level overview for the developer working with the crate.
Makes sense. How does this work with things like modules, too?
Yes. //. Comments can be used within modules as well to provide a summary of that specific module's functionality.
So, the regular // comment is for explaining a single function, but // is for context, a top-level look at the whole module or crate.
Correct. It's crucial for keeping documentation organized and user-friendly. A clear explanation helps people understand the relationships between different parts of your code.
What are the potential downsides to relying too much on // comments?
Well, if every module had a // comment, it would be a lot of repetitive work, kind of redundant. // needs to be used with common sense to help developers understand the project's context without being overly verbose.
So // comments add a higher-level organizational layer to the documentation.
Precisely, Matthew. // provides a way to document a larger unit of code. It's about the overarching design, while // is about the details of a single function.
Thanks, Russ Jackson. This clears things up nicely. This is invaluable for keeping our documentation well-structured and easy for others to use. Russ Jackson, welcome back to the show. Today, we're diving into crafting user-friendly public APIs in Rust. Can you give us a high-level overview of why this is important?
Absolutely, Matthew. Think of a library like a well-organized toolbox. If the tools are hidden deep inside drawers and cabinets, no one's going to use them. A clear, intuitive API is crucial for a library's adoption. Users need to easily find the tools they need.
So, you're saying it's about usability, not just the underlying code?
Exactly. The internal structure of your crate might be perfect for you, meticulously organized for your specific tasks, but it might be a total mess for someone trying to use it.
Okay, so how does the pub use keyword fit into this?
Pub use acts like a handy signpost. It takes a piece of code that's public in one location and makes it visible in a different location. Crucially, it allows you to redefine the user-facing API in a way that's easier to navigate than your internal implementation.
So, you're saying you can separate your internal structure from what the user sees?
Exactly. You can have a complex, multi-layered structure inside your library, but for your users' sake, you can expose only the parts they need, in a way that's clear and concise.
Can you give us a concrete example?
Sure. Let's say we have a library for artistic color mixing. Internally, we might organize colors by primary and secondary categories. But, using pub use, we can re-expose these types and functions directly at the top level of the API.
So, the users don't need to know about the internal kinds and utils modules to use the color mixing tools?
That's correct. They can simply use useart, primary color, and useart, mix. This makes the API much easier for users to understand.
What are the advantages of this approach?
It significantly improves the user experience by reducing the cognitive load and avoiding the need for users to navigate through lots of modules. It also allows you, the library author, the flexibility to rearrange your internal modules without affecting users.
So, it's a trade-off between your internal organization and user experience.
Absolutely. You can have a complicated internal structure but make your public API clean and straightforward.
What about potential disadvantages?
You could inadvertently create ambiguity. If you have similar named functions in different modules, a user might be confused. Careful design is key. You should always document these kinds of re-exports.
A great point. So pub use is a powerful tool for crafting clear, efficient public APIs.
Absolutely. It's a key aspect of building reusable and user-friendly Rust libraries.
Thanks, Russ Jackson. That was incredibly insightful.
You're welcome, Matthew. It's all about making your code accessible and useful to others.
Okay, Russ Jackson, Let's talk about publishing Rust packages on crates.io. First things first, what's the deal with this crates.io thing?
Crates.io is like the central marketplace for Rust packages. Think of it like NPM for JavaScript, but for Rust. You upload your code, other developers can download it, and it all gets managed centrally. It's a huge benefit for community collaboration.
So, to get started, you need an account. Tell me about the process of creating an account. What's the catch?
Yeah, you gotta sign up via GitHub. It's a bit of a lock-in, but it's how it is right now. It's probably to ensure account verification and prevent malicious activity. Maybe in the future, there will be other options.
Okay, and once you're in, how do you actually get that API key?
You go to your account settings on crates.io, find the API token area, and grab the key. It's a secret, so keep it safe.
So, it's like a password for accessing the crates.io platform?
Exactly. It's your access key to upload and manage your packages on crates.io.
And why is it so crucial to keep this secret?
If someone gets your API key, they could potentially publish malicious crates or even delete your packages. It's essential for security.
Got it. Once you have the key, what's the next step?
You use the cargo login command in your terminal.
Whoa, cargo login. What is that command doing?
That command tells Cargo, the Rust package manager, about your API key so it knows how to connect to crates.io.
So, you're basically authorizing Cargo to use your account?
Precisely. And it stores this key locally in your /.cargo/credentials folder.
Important security note there. That's why you should never share it.
Right. Always keep your API token safe and never share it with anyone.
So, if you mess up and share it, what do?
You have to revoke it and generate a new one. It's a good practice to do so if you suspect someone has access to it.
Great. So, if I had a successful Rust crate, how would I publish it to crates.io?
That's a whole other step, which we can cover another time. But the API key is crucial to get started.
Makes perfect sense. A good security practice to protect your creations and avoid malicious activities on crates.io. Thanks, Russ Jackson.
You're welcome, Matthew.
Thanks for the breakdown. Super clear. Now, where do you see this going in the future? Any potential trends?
Potentially more authentication options, but for now, GitHub integration is the standard.
Okay, Russ Jackson, publishing a new crate version, pretty straightforward, right? Just bump the number and...
Well, Matthew, it's more than just a number change. Semantic versioning is key here.
Semantic versioning? Explain that.
It's a standard for how you increment version numbers. Different types of changes warrant different version bumps.
So like a bug fix is different than adding a new feature?
Exactly. A patch is for bug fixes, a minor is for new features, and a major is for significant changes.
So, a new financial reporting module in your crate, that's a major?
Possibly. It depends on how much it changes the core functionality. If it's just adding data, it might be a minor.
So, if I made a whole new user interface for my financial planning software, major or minor?
Definitely major. That fundamentally changes the user interaction and is a significant improvement. Consider the impact on the overall structure and functionality.
Right, makes sense. So, how do I actually do this?
You change the version number in your cargo.toml file, then run cargo publish.
So, if I'm updating data structures that don't alter the core API, what versioning is best?
You're probably looking at a minor update. It doesn't change how your program interfaces with the rest of the system.
That's useful. What if someone accidentally publishes the wrong version?
It's a good practice to have thorough testing before publishing anything. Version control is crucial. You can always roll back to a previous, stable version.
So, are there any financial implications to consider here?
Yes, the financial implication of a new version of your crate is ultimately dependent on whether it generates revenue or not. If you are a library author, you may need to retrain your users about the updated version in order for them to gain full value from the update.
So meticulous version management has practical financial applications?
Absolutely. You're maintaining customer trust. You're ensuring compatibility.
So, is there any common mistake developers do when publishing a new crate version?
Failing to properly test the changes is a big one. You need to make sure you haven't broken things in the process.
What if the bug fix doesn't get caught in testing?
That's why it's vital to have a robust testing strategy and potentially even a beta testing phase with your users. This minimizes potential negative financial impact by getting timely feedback before a full release.
Thanks, Rust. Clear now. So, careful attention to versioning pays off.
Absolutely. It's all about managing expectations, keeping things clear and consistent. It builds trust, a key aspect for any software, including financial tools.
Great discussion, Rust. Russ Jackson, welcome back to the show. Today, we're diving into Cargo, the package manager for Rust. You've talked about dependencies before, but how can you actually manage a broken version?
Yeah, Matthew, a crucial aspect. Imagine a library update that breaks compatibility, causing havoc for projects using it. Cargo's yank feature is like a safety net.
So, you can effectively remove a version?
Not entirely. You're preventing new projects from using it. Existing projects that already depend on it aren't affected. Think of it like a temporary ban for new users.
So, a version's yanked, but the code still exists?
Exactly. The code isn't deleted, it's just blocked from being a dependency for new projects.
How does this work practically?
You use the cargo yank command, a simple command to prevent projects from relying on it.
How do you undo a yank?
You use undo with the command, allowing the version to be used again.
Okay, so, what's the command again?
Cargo yank, var 1.0.1 to yank, and undo to undo.
So, this is super important for, say, financial applications?
Absolutely. Think about a financial trading platform built on top of a library. If a security vulnerability emerges in an older version, you wouldn't want new integrations to use that version.
So a safety measure.
Exactly, a powerful security feature.
What if there's a mistake in the yanking?
The important thing is, it's not deleting anything. If you mistakenly yank a version, you need to immediately undo it. You'd be in big trouble if you deleted critical code by accident.
Okay, so it's not about deletion. It's about preventing future use.
Precisely. Think of it as a safety mechanism.
Counterexample?
Imagine a crucial library for financial calculations. A bug is found. We yank the old version. New users can't use that flawed library.
Excellent point. What's a potential pitfall?
Ensuring the undo is performed appropriately if there was an error.
How could someone accidentally introduce errors using this feature?
You could mistakenly yank a correct, critical version. So double-check before yanking.
Makes sense. So, a great tool for preventing further damage, not for getting rid of problematic code.
Exactly. A powerful tool in a developer's arsenal.
Thanks for breaking this down, Rust.
My pleasure, Matthew. Always happy to discuss the intricacies of Rust and Cargo.
Russ Jackson, thanks for being here. We've been talking about building packages in Rust. So, tell me about these Cargo workspaces. They sound like a way to organize things, right?
Yeah, absolutely. As projects grow, you might have a bunch of related crates, maybe a core library, a few utility crates, and a couple of command line tools. Cargo workspaces help manage all those related projects neatly.
So, it's like a project management system for Rust packages?
Precisely. Imagine a financial firm with separate apps for trading, risk management, and reporting. Each app might be a crate, with shared data models and functions. A workspace makes the dependencies and sharing easy between these different projects.
How does it work? What are the benefits?
You group all your crates into a directory. Cargo knows to treat them as a coordinated system. This brings in things like dependency management and build tooling across the group of crates.
Makes sense. So it's better than just having a bunch of separate projects?
Absolutely. Dependencies get resolved once for the whole workspace, and you don't have to track changes in each project individually.
That sounds like a time saver. Can we see an example of what a workspace looks like?
You wouldn't use code, but the key idea is that you'd have a root directory for the whole workspace. Inside, you'd find each crate as its own separate directory. They share dependencies, so your build system works together on all of them.
Okay, so it manages the dependencies better. Is there a downside?
Well, yeah, A larger workspace can slow down the build process if it has way too many crates and huge dependencies.
Interesting. So, like a large financial institution with hundreds of crates in their trading system?
Exactly. And also, maintenance can be more challenging if the teams are not working well together. So a good workspace needs clear roles and tasks, but also a clear understanding of the big picture, making everything easier to manage.
Sounds like communication and collaboration are key.
Totally. It's all about maintaining a consistent, clear structure. The advantage is that you can share code between different projects, but the structure of the dependencies and structure of the system must be clearly defined.
So, a financial application might use this for separate modules for different investment strategies?
Absolutely. If you had a core library for algorithms, a module for specific portfolios, and then, maybe, front-end modules for different client interfaces. The workspace brings all these together.
So, it's great for large-scale projects where modularity is critical for speed, efficiency, and clarity.
Yeah, it allows a team to work on different aspects of a project at the same time without getting tangled in the details of other parts of the code base.
This seems like a powerful tool. Are there any common pitfalls or misunderstandings people might have when setting up workspaces?
Sure. One common mistake is not clearly defining dependencies between crates. If you have ambiguous dependencies, then your builds are likely to be inconsistent and slow down your workflow.
So it's critical to establish and maintain clear dependencies to prevent conflicts?
Right. It's about clarity, explicit dependencies, and consistent communication. Workspaces can help keep things organized.
Thanks, Russ Jackson. That's really helpful.
You're welcome.
Russ Jackson, welcome back to the show. Today we're diving deep into cargo workspaces. You've talked about modules before, but what's a workspace and why is it important?
Hey Matthew, glad to be here. A workspace, in Cargo, is like a project folder containing multiple related crates. Think of it as a company with different departments, libraries, and a main office, the binary.
So, each department has its own code, but they work together?
Exactly. They share a common output directory, like a shared server. That's where all compiled code goes. Makes things a lot cleaner than compiling each crate separately.
Why share a target directory? Seems inefficient.
Well, imagine each department having its own compilation stage. It's like each department having to compile the whole company's code, which is redundant and slows things down dramatically.
So, this shared folder reduces recompilation?
Absolutely. When one part changes, only that part needs recompilation. The rest of the company, other crates, doesn't have to do the work again. This dramatically speeds up development cycles, crucial for large projects.
How does it apply to, say, a financial trading app?
Imagine a trading app with a library for order processing, another for market data, and a main app. By using a workspace, any changes in market data don't cause the entire app to recompile. The workspace greatly increases development velocity in complex software projects and greatly reduces bugs.
So, the workspace is a smart way to organize large projects and boost efficiency.
Yes. It's great for collaboration, too. Several teams can work on different libraries without stepping on each other's toes.
Are there any downsides or situations where a workspace wouldn't be ideal?
Well, if every single component depends heavily on every other part, a workspace might become less efficient. Imagine, for instance, a large complex network, with one crate's output influencing countless other crates' inputs. Or, if the crates are completely independent, a workspace might be overkill.
You're saying if the crates don't depend on each other, it might not be the best approach?
Exactly. In some circumstances where dependencies are minimal or non-existent, a standard crate approach might be preferable.
What about error handling in a workspace? What happens if one library has a major error?
The error would propagate, but Cargo will help pinpoint the issue. This is important because you get a more comprehensive, integrated build process without losing the benefits of independent library development.
So, if there's an issue in one library, Cargo helps pinpoint it and assists with debugging?
Exactly. It helps identify where the error is originating in the overall workspace, making troubleshooting much more efficient.
Thanks for clarifying that, Russ Jackson. It's clear now why a workspace is a vital tool for large Rust projects.
Definitely. The organization and efficiency gains are substantial for any project with multiple crates.
Great insight. Thanks for sharing your expertise with our audience. Welcome back to the show, Russ Jackson. Today we're diving deep into Rust Workspaces. So, tell us about these workspaces and why they're useful for managing multiple crates.
Hey Matthew! Workspaces are a fantastic way to organize projects with multiple crates in Rust. Imagine you're building a large financial application. You might have a crate for handling user accounts, another for stock trading, and a third for data visualization. Instead of managing dependencies between each project separately, a workspace ties them all together.
So, you're saying that it centralizes the dependencies, making it easier to manage a complex project?
Exactly. It's like a super project, organizing all your sub-projects, defining how they depend on each other, and allowing you to build the whole thing seamlessly. Think of it as a well-orchestrated symphony, where each instrument, crate, plays its part in harmony.
How do we define these dependencies within the workspace?
We specify them in the cargo.toml file at the root of the workspace. There's a special workspace section that lists all the project crates.
Okay, so we're adding a new crate, add one, to the workspace. What's the practical implication of this in financial applications? And how does it improve efficiency?
Imagine a user account management crate and a stock trading crate. The user management crate may need to verify certain account details, add one. Adding it as a dependency within a workspace integrates it into the complete system. It could validate account numbers with a separate crate that's specifically dedicated to financial computations and verification, boosting efficiency.
You mentioned the add one crate. What does it do?
It's a small library, a toolbox, if you will, containing a function to add one to a number.
So, the adder crate uses this function. Can you explain how this dependency setup works and what it looks like in the code?
The adder crate, a binary crate, depends on add one library crate. This dependency is declared in adder/cargo.toml. The path equals /add1 clarifies where the add1 library is located within the workspace.
This is clever, specifying the path like that. It's like saying, look in this other part of the house for the tools I need.
Exactly. It keeps everything neat and contained, and that's important for understanding dependencies within a large project.
And how do we actually use that add_1 function in the adder crate's code?
We use a use statement to bring the function into scope within adder/src/main.rs. Then we call it like any other function.
What if there's an error, like a missing dependency?
If a dependency is missing or broken, Cargo will report it. The build process will fail. It's essential to have a robust way to detect these errors.
So, Cargo build compiles all the crates?
Yes. It not only compiles add1 but also adder. It handles the dependencies properly.
What about running the adder binary crate?
To run adder, we use cargo run p-adder. The p flag tells Cargo specifically which crate to run from the workspace.
So, we have a central hub in the workspace, managing dependencies across many crates, making development more structured and less error-prone.
Precisely. It's like a financial firm using specialized tools, keeping everything organized, and clearly defining who's responsible for what.
Fascinating. This workspace approach is a clear win for complex projects, even in the financial sector. Thanks for breaking it down, Russ Jackson.
My pleasure, Matthew.
Welcome back to the Rust Zone, folks. Today, Russ Jackson, our resident expert, is diving deep into Rust Workspaces. Rust Workspaces, what are they and why should we care?
Hey, Matthew. Workspaces are a great way to manage multiple crates in a single project. Think of it like a well-organized filing cabinet for your Rust code.
Ok, affine un cabinet. So, practically speaking, how does this help us?
Well, imagine you're building a large application. You might have different crates, like a database crate, a UI crate, and a business logic crate. With a workspace, you can keep all these crates together, making it easier to manage dependencies and build the whole thing at once.
So, you're saying it's easier to collaborate on, say, a finance app this way?
Absolutely. If you're working on a finance app with a team, everyone can develop their crates without messing up another's work, just like different departments in a finance company.
Okay, but how do you actually structure this? Let's break down the code example. What's happening there?
The example showcases a workspace with two crates, add one and adder. You run tests for each or just one part of the workspace. Crucially, it demonstrates how to run tests for just one of the crates inside a workspace.
Interesting. So, it's not just about managing multiple crates, but running tests specifically for one?
Exactly. You can use cargo test p-add1 to focus on testing just the add one crate.
That's pretty cool. So, running tests on a workspace, does it run all the tests, or can you be more selective?
You can be selective, a key feature. Cargo test will run all the tests in all crates within the workspace, while cargo test p-add1 will only run the tests in the add one crate.
What happens if there are conflicts?
Potentially, there can be conflicts between the versions of dependencies if you're not careful. It's a good practice to carefully manage dependencies within the crates themselves. A well-defined workspace structure generally reduces this issue.
So, what if we want to publish to crates.io? Each crate has to be published individually?
You bet. There's no all or p flag for publishing. You need to move into the directory of each crate and publish it manually. This is important. You can't publish all crates at once.
So, is there a potential downside to using workspaces? Maybe for smaller projects?
Well, for incredibly small projects, a workspace might be overkill. But as your project grows, it becomes a vital tool for structure and organization. It streamlines testing, and collaboration becomes significantly easier.
Sounds like a better organizational structure for building complex financial applications, for instance.
Absolutely. It's all about scalability and maintainability as your project grows and evolves.
Great insight, Russ Jackson. Thanks for shedding light on Rust workspaces.
Thanks for having me, Matthew. Always a pleasure discussing Rust.
Russ Jackson, welcome back to the show. We're diving deeper into Rust today, and specifically how to install tools from crates.io. Can you give us a quick overview of what Cargo Install does?
Sure, Matthew. Cargo Install is a handy tool for getting pre-built binary tools from crates.io, the Rust package repository. Think of it like downloading and installing software from a package manager.
So, it's not for libraries, just for executables?
Exactly. You use it for programs you want to run, like command line utilities. Libraries, on the other hand, are components you'd include in larger projects.
Okay, why not just use system packages for these tools like grep or find? What's the benefit of using Cargo Install?
Well, Cargo Install often provides more specialized tools, sometimes faster or more tailored to Rust projects. Plus, these tools might be built specifically for working with Rust code.
So, what does it mean for a crate to have a binary target?
A binary target is the runnable program that a crate builds. It often means there's a src/main.rs file defining the program. Libraries don't have main functions.
You mentioned ripgrep. Why would someone use that over grep for file searching?
Ripgrep, or RG, is a very fast, modern Rust-based grep implementation. It's often better for handling large files or projects with complex search patterns.
Okay, where does Cargo Install put these binaries?
In the bin folder within your Cargo installation directory. Usually, that's $home/.cargo/bin for typical Rust installations.
So, how do you ensure this directory is part of your shell's path?
You need to add the $home/.cargo/bin path to your system's path environment variable. Otherwise, running the commands you install will fail.
Right, this is crucial for actually using them. So you're saying ripgrep is often faster than grep in some cases. Does that hold up for every use case, though?
Not necessarily. For simple searches, grep might be sufficient. But when dealing with large projects or specific file structures, ripgrep could offer noticeable speed and performance gains.
I see. How would you explain this to a non-technical audience, someone who is not a programmer?
Imagine grep is a basic search tool. Ripgrep is like a supercharged version, tailored for modern, larger files and data.
What about troubleshooting if you encounter issues installing a crate this way?
Check your internet connection, make sure the crate is valid, and double-check your path. If it's not working, look at error messages for specific hints.
Thanks for clarifying that, Russ Jackson. The why and how behind Cargo Install are clear. It's a useful tool for efficient work.
Indeed. It's a valuable part of the Rust ecosystem. It allows you to utilize the power of the Rust community's tools.
Excellent. Thanks for the insight. Russ Jackson, welcome back to the show. We're diving deeper into cargo today. So, you're telling me cargo is extensible? Like, you can add new commands?
Absolutely. Cargo is built with extensibility in mind. It's a really smart design.
So, how does this work practically? Give me a real-world example.
Imagine you need a special command to, say, analyze your code for potential financial vulnerabilities. You could create a binary, let's call it cargo fincheck.
Okay, so you're saying a separate tool? Not built into cargo itself?
Exactly. And you'd put it in your $PATH. Then, you could run cargo fincheck and cargo would execute that tool, just like it would any other cargo command.
So, it's like a plugin system for cargo?
That's a good way to think about it. You're extending cargo's functionality without changing cargo itself.
That's super cool. What are the advantages of this approach?
It allows for independent development. If someone builds cargo fincheck, I can easily use it. No need to modify cargo itself, keeping it clean and stable. It's like having a modular system.
How does it handle installing these custom commands? Do I have to compile them?
Yes, typically you use cargo install. You install cargo fincheck the same way you install any Rust package or tool. That installs the binary, puts it in the right place.
That's elegant. What about updates? If the creator updates cargo fincheck, how do I get the updates?
You would reinstall it using cargo install again. It's just like any other package update.
Now, let's say I'm worried about conflicts with the standard cargo. What safeguards are in place to avoid that?
Well, you could get naming conflicts, theoretically, but cargo's design is carefully constructed to minimize this. The crucial part is that the new tool uses the cargo prefix.
Okay, so if there's a cargo something command, it's not going to accidentally interfere with existing cargo commands?
Exactly. That's the crucial part that prevents major conflicts. And importantly, custom commands like cargo something are listed when you use the cargo list command, so you always see all the commands available to you.
So, you could potentially use these external tools to automate financial analysis on Rust code.
Absolutely. There are many ways to leverage this. This could lead to new tools for security analysis, optimizing performance, testing code across diverse financial contexts. There are lots of use cases.
This sounds like a powerful extension mechanism. Russ Jackson, so what are potential drawbacks?
Well, you might encounter dependencies. Your cargo something might depend on external tools. If those are not available or updated, it could cause issues.
Interesting. Any common pitfalls developers encounter when trying to create custom cargo commands?
Sometimes, folks might try to modify the core cargo code itself, rather than leveraging the extensibility. Or, they might misplace the cargo something binary, which could lead to runtime errors.
So, remembering to put it in the correct location in your $PATH and understanding the dependency chain are crucial.
Absolutely. You want to ensure everything works seamlessly.